Hi, welcome back to Psych 5316. In this video, I'm going to walk you through the process of building a Sternberg memory scanning task. So your first question is probably, what is a memory scanning task? Well, this is some work that goes back to Saul Sternberg in the late 60s, who asked the basic question of how is it that people access the contents of their short-term memory. So to get at the answer to this question, Sternberg did the following. He put participants through a task in which first the participant is given a list consisting of n different digits. And so n is a number that varies between 1 and 6. So some of these lists contained only one number, whereas other ones contained anywhere from 2 up to 6 numbers. These digits were called the memory set. This is the thing that the participant is supposed to rehearse and keep in short-term memory. Now, after that, after the participant rehearses the list, a few seconds later, the participant sees a single digit. This number is called the probe, and the task is that the participant must indicate whether that probe digit was in the original list or was not in the original list. And so you do that over and over again, and you measure response times, and Sternberg was able to make some conclusions about how it is that people scan the contents of their short-term memory. So our task is to build an experiment that replicates the original Sternberg experiment. The experiment structure is pretty simple this time. There's only 2 blocks in the experiment. There's going to be a practice block and then the main experimental block. And within each block, we will have the following trial structure. So each trial will begin with a fixation dot, which will be presented for 1,000 milliseconds. Then we will present the memory set. This is the list that they are supposed to rehearse. That'll be presented for 1,200 milliseconds. These numbers, by the way, come directly from the Sternberg 1966 paper that was published in Science. After the memory set is presented, there will be a blank screen, an interstimulus interval, or ISI, for 2,000 milliseconds. Then the probe digit will be presented, and that will be displayed until a response is given, after which there will be a screen that presents feedback, either correct or incorrect, for 1,000 milliseconds. Then the trial loops over and goes through the experimental block. Now, what are the stimulus manipulations? Well, basically, we have 3 things that we're going to manipulate. We're going to manipulate the memory set size, so that's going to be anything from 1 up to 6. So there'll be 6 different set sizes that will be presented to the participants. Now within each of these set sizes, the probe will be either from the list, which we call present, or not in the list, which we call absent. And then we will also manipulate the position of the probe in each list. So this is going to be variable depending on the memory set size. For example, if the memory set only contained 1 digit, if the probe is present, it can only be in one place, the first position. But if you go all the way up to a memory set size of 6, then the probe could have either been the first digit, or the second digit, or the third digit, or the fourth, or the fifth, or the sixth. So you can see that that position variable is going to be dependent or is tied to memory set size. So for each of the conditions that you get by crossing these 3 manipulations, we're going to have 3 repetitions of each condition. So that sounds like a lot. How many trials is that in total? Well, you can think about it in the following table. If you look at the different set sizes, 1 through 6, there's 2 probe conditions, either present or absent. There's 1, 2, 3, 4, 5, 6 different positions if you go through a set size of 6. And then for each of those, there's 3 reps. So for the first row, there's 2 times 1 times 3 equals 6 trials that we're going to present for n equals 1. And then 2 times 2 times 3, or 12 trials for n equals 2. Continuing the multiplication, we result in the following numbers of trials for each set size. And if you add all of those together, you get a total of 126 trials. So that's what we're going to present to our participants, is a set of 126 trials. So it shouldn't take too long for each participant to do the experiment. Now, before we can get started on the actual building of the experiment, we need to download a couple of files. Because the experiment structure is somewhat complicated compared to our last experiment, we need to go ahead and have all of the stimuli in a file. And one way that Open Sesame does this is it lets you read stimulus and variable definitions from an Excel file. And so I have gone ahead and put 2 XLSX files. These are just spreadsheets that you can get from Microsoft Excel or OpenOffice. And these contain our stimuli that we're going to be using both for the practice block and the experimental block. They're already posted on GitHub. If you can just go to this following little shortened GitHub address, git.io/lowercase fx, uppercase j, lowercase xv. If you go there, then you will be going to my GitHub page. Give it just a moment for that to load up. And then down here under week 6, you will see these two XLS files, prac trials and main trials. What we need to do before we start building the experiment is save those files somewhere on your computer. And so you can right click, or if you're using a Mac, you can control click and save the link as something on your computer. I've already done this, so I'm not going to go through the process from here. But you need to save these files onto your computer. And then you need to open up Open Sesame, which we will do now, except Open Sesame has somehow closed on me, so there we go. So get into Open Sesame and start up a new experiment. So you should get something kind of like this little menu right here. Now, a lot of the orientation of Open Sesame was contained on the first video where we built the flanker task, so I'm not going to go through that this time with you. This time we'll just start with a blank experiment. Now remember, if you just use the basic default template, it gives you these two little screens, which we're going to get rid of. Remember, if we control click on the element, it'll let us permanently delete, and that's what we want to do here. We don't want these anymore. And now we have a very bare bones experiment. So the first thing we're going to do is we're going to click on the this top label that says New Experiment. We're going to change that name to something a bit more descriptive. I think we'll call this Sternberg Task. Okay. And the only other thing that we need to change on this screen is we're going to change the back end to be the legacy one. Okay. You can use the other ones, but sometimes I have issues with those, and so for maximum stability and maximum compatibility across all of my students who will be doing this, I use the legacy back end. And that's all we need to change there. And at this point, we're going to go ahead and save the script. All right, so we'll hit File and Save, or Apple S, or Control S. And I'm going to save this on my desktop for now. Okay. Now at this point, we're ready to start building the experiment. So remember, the experiment itself is this little sequence. And what we're going to start with is we're going to insert a loop into the experiment. So we drag the loop item into experiment. It comes in and calls it new loop. I'm going to call this practice loop, like so. Now, if you remember the video from the flanker task, this is where we built all of our stimuli and all the variables. But again, the structure on this experiment is a bit more complicated. So what we're going to do this time is, instead of building it in this table, we're going to call in one of those Excel files that we downloaded. So we go down here to where it says source. If you click on that, it gives you the option to do a file. Okay. Now, there's no file to put there. We need to browse. And what we're going to be browsing is something called the file pool. This is a set of files that you have added into Open Sesame to use within the context of this experiment. And as you can see, there's nothing in here yet. What we need to do first is we need to add some files to our file pool. So I'm going to click on the little plus sign. And it's going to open up a dialog based on the file structure of your computer to find those Excel files. Now, I put them in a specified location. You'll need to go to wherever you put the XLS files. So I want this main trials.xlsx, as well as, so let's go ahead and open that. And then I'm also going to add the prac trials.xlsx. You have to have two files in your file pool. Now, since this is the practice loop, I am going to select the prac trials.xlsx and go from there. Now, one of the disadvantages of doing this is that there's no display of what things are down here. You don't know what your different variables are. So it might not be a bad idea to go ahead and open up those the prac trials.xlsx just to see what the structure of that is. I'm going to do that for you real quick. And this is a little bit too big for the screen, so let me, well, you can see it within the screen here. So it's got several columns: block, set size, position in set, present, yes or no, number set. This is the thing that is presented to participants. what the target is, and what the correct response is. So you can go through and look at this, but you don't have to edit it at all. This is already built just for seamless integration into Open Sesame. Okay, so I'm going to get rid of that. We're not going to go back to look at that, but that's an idea of what things look like. Okay, so we'll go back to Open Sesame. We now have our loop in place, and we are ready to build the experimental sequence within this loop. So to do that, we're going to drag one of the sequence items. This is the one with the arrow. And remember, when we drag it onto a highlighted portion, it gives us the option to insert into the loop, or after, we want to put it inside the loop. Now this says new sequence. I'm going to give it the descriptive name of exp sequence. You can call it whatever you want, but I suggest that you do things as simply as possible. Now we're ready to go back and finally build the structure of our experiment. So if you remember from the brief presentation before we started building, we start with a fixation point. So we're going to drag one of these sketchpad items into the sequence. And we're going to display, first of all, we're going to name it fixation. We're going to display it for 1,000 milliseconds. And then I'm going to use this little dot right here, right in the center, as my fixation. Okay. So I'll hit save. I always like to hit save after every new thing is added. The next thing will be the memory set. This is the thing that gets presented. So we drag it in after fixation. I'm going to call this memory set. This will be displayed for 1200 milliseconds. And what it consists of is some text. It's going to be in the center. So we hit the little text thing and click on the center. And the text we want to put is variable. Remember, this is going to be pulled from that spreadsheet. And then the variable that we're going to be using is called number set. So remember, to put in something that is variable, I put it in brackets. And I'm going to say open bracket, number set. The S is capitalized. That's very important. And then close brackets. Now that's kind of small, so I'm going to crank the font size up to 30. Oops, that's very small. Let's try 36 point. There we go. So everything else stays the same, but I'm going to change it up to 36 points so it shows up nicely on the screen. And remember, when the experiment is run, this will be replaced by whatever is in the column number set in the Excel file. After the memory set, we're going to present a blank screen. So we'll put another sketch pad. We're going to call this ISI for interstimulus interval. We don't have to put anything on the sketch pad, but we do have to display it for 2,000 milliseconds. After the blank screen displays for 2,000 milliseconds, we want to present our probe. So we'll drag a new sketch pad in. We're going to call this probe. Now we're going to set the duration to 0. Remember, whenever we do something like this, anything that has a keyboard response following it, which is what we're going to do here in a second, you need to display this for 0 milliseconds, and then it will immediately go to the waiting keyboard response. Otherwise, this displays for a certain amount of time and then goes to the keyboard response, which is not really what you want. So we set this at 0, and we're going to put some text in the center, but this time the text will say target. Remember, target is the column in the Excel file which contains our single-digit probe. Now again, that's pretty small, so let's change this to 36 point. So now we have our fixation point, our memory set, a blank screen, and a single-digit probe. Now we need to put in something to collect the keyboard response. Now, the way we're going to do this is we're going to have participants press either the left or right arrow key on the keyboard. So the allowed responses are going to be the keys left and right. Right? And the way Open Sesame realizes what those keys are called is by the words left and right. And remember, we separate those with a semicolon. Now, the default is an infinite timeout. That is, we let them just go on as long as possible. But sometimes that results in some really big outliers in your data. So I recommend setting something reasonable like 2,000 milliseconds. So if they don't respond within 2,000 milliseconds or 2 full seconds, it moves on to the next trial. Okay. Oh, and we forgot to rename this. I'm just going to call this keyboard response. It's the only one we're going to use through the experiment, so just saying keyboard response should be fine. And we'll hit save. So now this collects the keyboard response. We need something to record it, and that's what a logger is for. So we'll put a logger in after the keyboard response. Again, take the new off of it, just call it logger. And remember, by default, I like to just log all variables, and that will be fine. The last thing in the experimental sequence is I want to put in a couple of feedback screens. So we're going to put in a sketchpad, which we'll call correct feedback. So this is the thing that will present when they're correct. We're going to present it for 1,000 milliseconds, and it's going to consist of the word, oddly enough, correct. And put an exclamation point on there. Let's be exciting. That's kind of small, so let's fix it up a little bit. Let's make it green, and let's make it 36 point. There we go. Hit save. And then let's do the same thing for incorrect feedback. So another new sketchpad, incorrect feedback, present it for 1,000 milliseconds. This time we'll put the word incorrect with an exclamation point. And we'll color it red. And once again, change it to 36 point. And that is the experimental sequence. Now, there's one thing we haven't done yet. If you click on the EXP sequence item, you'll notice that every one of these always runs. Well, we want the correct feedback and incorrect feedback to be conditional. We only want correct to display when they're correct, and we only want incorrect feedback to display when they're not correct. So we need to change this part right here from always to something that's conditional on whether they're correct or not. So if we double click on the word always, we have the opportunity to change it to, and you'll remember this from the flanker task video, if the variable correct equals 1, remember that's the code for a correct trial, then it will display correct feedback. If the correct variable equals 0, that's an incorrect trial, and it will thus display the incorrect feedback screen. Everything else we want to always run. Okay. So at this point, let's just do a little test. We're going to do the little double arrow right here on the right, or you can go up to Run and Quick Run. And let me make sure that the little Quick Run pops into your viewable screen. So 4.8 has been presented. Now was 4 in it. I press the left, and that is correct. Now I've got a longer one, 578.412. Was a 6 in it? No, so I press the right one. Now let's get one wrong. 96745. Was there a 3? Yes, so let's press, oop, I got the wrong one. Sorry about that. 415. Okay, and then I intentionally got it incorrect. So we can see that our feedback all works. I don't want to go all the way through this, so I'm going to hit Escape and then Q to quit. And it tells me that I messed up, and that's okay. We know that the sequence is working correctly now. Okay, so now we've got the practice loop. We want to do an exact copy of this for the experimental loop using this exact same sequence. Let's put in a new loop. So we're going to drag a loop item onto practice loop. And the reason I do that is because it now lets me do after the practice loop. It puts it down here where I want it. I'm going to call this experiment loop. And the only thing that I have to do different is I have to change my source to a file, just like before, but this time I'm going to use the main trials.xlsx. Now, if you didn't add this to your file pool earlier, it won't be there, so you'll have to go in and hit the plus sign to do so. But I've already added it there, so I don't have to do that. I'm going to hit main trials.xlsx and select. Now, I've got 126 stimuli ready to be put in. Now at this point, what I want to do is not reinvent the wheel. I want to use every one of these things the exact same way. I just want to call them from the stimulus table that's called main trials. So the way I do that is I go up here to experiment sequence, highlight it, and I control click or right click on that name, and I do a linked copy. Okay. And now I go down here, click on my loop, my new experiment loop, and do right click or control click, and hit paste. And this lets me put it into the experimental loop. Now you can see that I've got the exact same sequence appearing in the practice loop as well as in the experimental loop. And so now I've got the exact same experiment structure. I'll run through all the practice loop trials, there's 12 of them, and then I'll go directly into the experiment loop trials. And that's exactly what I want. The last thing that we need is we need to put some instructions in here. So this is usually the most tedious part. Okay, let's put some instructions in. So we'll put in some instructions right before the experiment sequence first. So right inside right before the practice loop. Okay. So we'll call this instruction 1. Okay. All right, here we go. Now we're going to put in some text right here in the center. And we're going to type in a lot of text. So I'm going to say what it is that I'm typing here. In this experiment, you will be presented with a sequence, and I'll go ahead and hit return because I want this to not just run off my page, of between 1 and 6 randomly ordered numbers. Now I'll get some space, go down the next line. Following a short delay, you will then be presented with, now let's hit return, a single number, and you will have to decide whether this new, hit return, number was a member of the sequence. Let's get a little bit more space. Now we're going to tell people what to do. Press the capital left capital arrow key if the number, and I'm going to say was in all caps in the sequence. Get yourself some space and do this now for the right arrow key. Press the right arrow key if the number was all caps not in the sequence. Now we'll go down another one and we'll tell people what to expect first. There will be a number of practice trials in which you will hit return, be given feedback. Try to respond as quickly and as return accurately, spell it right, as possible. Now the last line, when you are ready to proceed, press either arrow key. Okay, let's see what that looks like. Okay, it's kind of small. I think we can fix it up if we change it to maybe 24 point. Yep, that's quite a bit better. So when you see that presented on the screen, it'll look pretty good. Okay, so now this is ready to go. It stays there until the person hits a key press, which is exactly what we want. Okay, so now that gets them ready for the practice loop. We're going to do now something similar, but it's going to be after the practice loop. So I'm going to insert this on practice loop and say after. So now it puts it down here after the practice loop. And we're going to call this instructions 2. Now what do we want to type in instructions 2? Well, something similar to the last time, a little bit shorter though. We kind of want to remind them of what the response mapping is. So here's what we can say. Again, we'll put the text item in the center and type the following. Okay, ready to start the main experiment. Okay. Now we'll go down a couple of spaces. Remember, colon. Now I'll indent a little bit. I'm going to give them kind of like a little bulleted list here. Dash, press left arrow for in the sequence. Return. Indent, dash, press right arrow if not in the sequence. So again, we're not really giving them a lot of detail, we're just reminding them of what the response mapping is. And we also remind them in the next line, try to respond as quickly and as accurately as possible. And then finally, when you are ready to proceed, press either arrow key. Again, the purpose of that is to get them on the response keys right now. If they press just like the space bar, then when the first trial comes up, they have to move their hand around. So I like to just have them proceed using one of the response mapping keys. So again, that's pretty small. Let's change this to 24 point. That's much better. That gets them into the experimental block, which is the longest one. Once they finish that, we're done. So we just need a little thank you screen. So last thing that we'll do is add a sketchpad item onto experiment loop. We'll put it, sorry, that didn't work. Try again. We'll put onto experiment loop and after. That puts it down here at the bottom. And we'll call it thank you. And right in the center, we'll say something generic like, thank you for your participation, with an exclamation point. And as always, change the font to be a little bit bigger. There we go, folks. That is a Sternberg experiment. So remember, to run the experiment and collect data, you need to go up to Run, and you want to run it full screen on your own computer. For the video purposes, I'll run it in Window to demonstrate. Put in the subject number. You guys in your assignment will be asked to collect this from 3 different participants, so it'll be either 1, 2, or 3. So I'll say 1. And then you need to save it somewhere. Desktop is fine. You can save it in a folder, and then it should begin. And you can't see the whole screen, but you can see kind of what it looks like. Let's just make sure it works. So there's the memory set. There's the probe, and it was in there, and it gives feedback. And it's just going to keep doing that over and over again. All right, so I'm going to get out of this by pressing Escape and then Q. And that's all there was. Okay, so hopefully you can go through those steps and build yourself a fairly complex experiment without too much programming overhead. And hopefully it works. Of course, if it doesn't, always send me an email. Let me know what's going on. And hope it works out well for you. So until next time, we'll see you later.